Welcome back, everybody. In the last video, we set up our AI manager, which I think was actually relatively simple, seemed pretty seamless to me. We created two services, a mock AI service and an open AI service. Obviously, the open AI service is actually interacting with the OpenAI API through a Swift package. And at the end of the last video, we actually had the ability to go ahead and create images in our Create Avatar screen. So now we can actually create an avatar. I'll go ahead and I'll make a dog that is drinking in the museum, and we can generate an image. So now that we have the avatar created in memory, let's go ahead and save these avatars to our database because we want to then fetch the avatars later. So the first thing is I want to think about where am I going to put the code for creating avatars. We did make an AI manager, but the question is creating an avatar and saving an avatar and later fetching an avatar, does that have anything to do with the AI dependencies? And it does not. So we're going to generate an image, but actually saving and fetching an avatar is just interacting with Firebase. It's not interacting with the AI manager at all. So we could put a second service in here, creating and fetching avatars, but even that wouldn't really be part of an AI manager. It probably should be closer to an avatar manager. When I go and I look at our database, we also might have the thought of putting our logic into the user manager. So the user manager manages everything with the user profile. But in our database, we're going to create another collection here, separate from the users collection, that is going to be called our avatars collection. And so we're going to store the avatars separate from where we store the users in the backend. So what I'm getting at is generally if the data is going to be separated on the backend, I also like to separate it on the front end. So we could put all of the avatar stuff inside the user manager. There's a lot of apps that do something like that where there's one monolith, one big manager that has everything to interact with Firebase. But I think that it's going to be cleaner to actually create a separate manager specifically for the avatars. So that's what we're going to set up in this video. Let's jump into our services folder, and we already actually have an avatar folder. Now let's go ahead and right click and create a new file called the AvatarManager. And I'm going to challenge you guys to set this up on your own. So firstly, we're going to create the manager, then go ahead and create the protocol, and then create two instances of the protocol. So we'll create a AI manager, an AI service, and then a mock AI service and a Firebase AI service. Do it all in this file for now, and then we're going to go ahead and move it at the end of the video. So challenge yourself, see if you are understanding how to actually set up these data layers. All right, and without further ado, I'm going to get started here. Let's actually I'm going to jump to the AI manager and just copy this, bring it into the avatar manager. Let's rename it Avatar Manager. Let's make an avatar service. Let's delete this and make this an avatar service as well. So we're going to need a protocol called avatar service. We're going to need a struct that is a mock avatar service. Will conform to avatar service, as well as a struct that is a Firebase avatar service, type avatar service. And I will point out here, while we're doing this, this architecture also opens us up to change out our dependencies for different parts of the application. So you could imagine that maybe we use Firebase for authentication, but we use a different backend database for the user manager. And then we use a different backend database for fetching and saving the avatars. So now each of our dependencies can be completely decoupled from each other. Even though we're using Firebase for most of the dependencies, we actually could now use totally different dependencies for all of these different services. Let's jump into our Create Avatar view. And we already had some code here. Let's go down to the bottom. On Generate Image pressed, we're taking the description, we're generating an image, that's all great. And then we have on Save pressed. On Save pressed, let's go ahead and make a comment here. This is dismiss screen code. But in here, instead of this sleep, we actually want to save the avatar to our database. So when the user clicks on Save, we should take the name, the attributes, and the image, create an avatar, and then save that avatar to the backend. So in here, let's go ahead and say let avatar equals avatar model, option enter, triple click, control M. What ID do we want to give this avatar? I don't really care what the ID is, so let's go ahead with a UUID.string, just a randomly generated string. For the name, we're going to take the avatar name that we have at the top of our code. Now this name should not be empty because we already had a little bit of validation that if there is no text here, the generate image button would have not worked. So generally we know that there's going to be string here. But let's also add a little bit of validation before we save the name, because when we save these avatars, they're going to go out to everybody in our app. So let's go ahead and reuse our text validation that we made on the chat screen. So we'll do a do catch statement here. And let's say try text, what is it? Text validation helper dot check if text is valid, and let's put in our avatar name. And let's remember, check if text is valid is making sure the minimum character count is 4, and as well as there are no bad words. I'm actually just going to pass in the minimum character count of type int, set it equal to 4 by default, and I'll delete it from here. So now we can customize the character count if we want. So for example, I could do, maybe the minimum character count of an avatar is actually 3 characters rather than 4. Let's take our avatar code and put it here. So now if it throws an error here, we have to catch that error. Let's go ahead and put that error on the screen. So again, in our chat view, we already created reusable components for this. So show alert, I will copy, and let's put it in here. And in our chat view, we also have the show alert modifier, which I will copy and put in here. And at the bottom, I can just put the show alert equal to any app alert from the error. So we'll test that in a second, make sure that it is working. The dismiss code into the success area of the do catch. And then also, if this is your app, you can also add additional validation. Maybe you want to make sure that it's one word. Make sure you want to make sure that the first letter is capitalized. A whole bunch of different things you could do to add additional validation here. The character option is going to be the character option that is selected at the top, the character action, and the character location. This avatar model does not have an image yet. We're going to need to go and upload this image to actually get the image name where it's going to be in our database. So for now, we'll just keep this as nil. The author ID is going to be the current user ID. So at the top here, let's go ahead and pull in our auth manager. This should be the auth manager. When we do that, we're going to have to add that to our preview. So in our preview, I'll add a .auth.environment. Let's go auth manager, mock auth service, and I'll make sure that the user is signed in for our mock for now. So here, let's go ahead and say let UID equals try auth manager dot get auth ID. This was the throwing function we made for convenience earlier in the course. So the user ID will go here. They created, of course, is right now. Now let's go ahead and upload. We need to upload the avatar as well as the image that is at the top of the screen. So let's jump into the AvatarManager again. In here, let's create a function called createAvatar. We will pass in our avatar of type AvatarModel, as well as the image, which is of type UIImage. Let's make sure this is asynchronous and throws in case it does fail. All right, the first thing we need to do here is upload the image, and then we need to upload the avatar. All right, to upload the image, we're going to use Firebase storage, which is, again, separate from the database, but it's where we store assets like images and videos and audio files in Firebase. So if I jump back to the Firebase console, let's jump open to the build tab and go to the storage section. And let's get started. Let's start in test mode. Go ahead and click next. We can't change the bucket. It has to be the same as our Firestore bucket. Click done, and then this will set up our storage. I will link below a video on how to use Firebase storage. Again, I did that on YouTube. Because I did that video, I'm going to move quickly as we set it up in this video. Great. Now that that's set up, let's jump into our code base and let's create an image uploader file. I want to make this reusable. so that I can upload images not just for the avatar, but any image that I want to upload. I will use the same uploading service. Now, uploading images is going to be separate from uploading avatars. So let's go ahead and right-click in our services, create a new folder, and I'll call this image upload. Our image upload is not going to need a manager that I share across the application. I'm just going to create one every time. So I'm just going to create the services for this. But I want to keep it in the same structure as all of my other services here. So we have the folder, the parent folder, and then we have a folder called services. So in here, I'm going to create another folder called services. And then let's right click, create a new empty file. And I'll call this the Firebase image upload service. All right, this will be a struct called Firebase image upload service. In here, let's create a function called upload image. And we're going to need to import Firebase storage, which we don't have in our project yet. So let's go to the navigator. We are going to go to the targets, come down to our target here, and let's look for the storage package from the Firebase SDK. We don't need to use Combine, just the Firebase storage. Go ahead and add it to the project. Now let's go back to our file and import Firebase storage, which I'm not seeing. Command-Shift-K to clean, and hopefully storage pops up now. I will also import SwiftUI, and when we upload an image, we'll pass in the image of type UI image, as well as a path of type string. This will be a synchronous function that throws, and it's going to return us back the URL for where that image is in the storage container. Again, I'm going to move fast here because I covered this on YouTube. If you want to go into detail on how this works, just look at the video linked below. Firstly, let's get the data from the image. Guard let data equals image dot, we'll do the JPEG data, and I'll compress it at 1, so basically 100% of the exact size. We could compress it more if we want. We could turn this to a PNG if we want. JPG is the most basic. Let's say else. If there is no data, let's go ahead and throw a URL error dot, let's just call data not allowed. I'm just getting lazy here and I don't want to create custom errors. You absolutely can go and create custom errors here in your code if you want. In order to upload it, we're going to need a reference to where we're going to actually save it in the Firebase storage container. First, let's create the image name. So the file name is going to be let name equals, and we'll pass in the path .jpg. Secondly, let's get a actual reference to the path in the database. So we'll call storage.storage.reference with path, and we'll pass in the name here. So this will go into the Firebase storage, whatever the path is, and then name the file .jpg. Let's make this reusable in case we want to change the path for some other function. So down here, I'll create a private func called image reference. In here, I'll pass in a path of type string and return a storage reference. So I'll cut this and just return this from this function. Let's try to upload the image now. So in here, we'll say try await. Let's get the image reference, pass in the path, and we'll say .put data async. So the Firebase storage team does actually give us an async await method here. I will click Option Enter on this. So put data, the data is going to be the data from the image. And then we need to create some metadata here. So let's go ahead and say let meta equals new instance of storage metadata. And we'll set the meta.content type equal to image \JPEG. This one is JPEG and this is JPG. It does work. I don't understand why the difference is there, but just pointing it out, I did not make a typo. Let's pass in the metadata. And then this on progress closure is if we want to get progress back as it uploads, but we are not going to worry about that. It's going to upload pretty quickly anyway. It's just one small image, so we'll delete that. Getting compiler warning, the result of this is unused. If I hold the option button and click on this, we can see that this returns us back storage metadata. So I'll call this the let returned meta equals the result of that. And now from this returned meta, we can try to get the URL, we can say guard let returned path equals returned meta dot path. And we can say let URL equals URL string from the returned path. And we'll say else. And again, let's go ahead and just throw a URL error. We'll do .bad server response if it returns us back no URL. And now we could return the URL that we got back from it. This will compile and this will work, but the URL that we're getting from this returned meta, I actually think is the wrong URL. So we're going to add one extra step into our code, just because I've used Firebase for so long that I know some tips and tricks about how to use Firestore. So I'm going to cut this. Let's go ahead and make this a reusable function. Private func save image. So this code in here is all about saving the image. Async throws, and this will return us a URL, even though it's not the URL we're going to actually use. In here, let's pass in the data of type data as well as the path of type string. All right, so in here we'll say let URL equals try await save image data and path. All right, now this is uploading the image. After we upload it though, let's go and reference the same path and just get a new download URL. So I actually don't want to use this URL. Let's put an underscore here. And then let's go ahead and say let URL equals, let's access the same image reference. Let's go to the path, the same path. And there's a method here called download URL. And this retrieves a long-lived download URL, which can be used to share the file with others. This can be revoked by the developer, but we are obviously not going to revoke it. So this is the actual download URL that I believe will work when we use like async image and we use our SD web image. So that's what we're going to do and return back this URL here. Let's go ahead and make this try await, and we will just return the URL from there. So here we will upload and then get download URL. Just like that, we have a Firebase image upload service. We can then go and create a protocol called image upload service. In order to conform to image upload service, you need to have this method in your code base. I'm not going to create a mock just because we don't need one, but I think you guys would understand just how easy we can now use either a different image uploader or a mock one just by conforming to this simple service. Let's jump back into our AvatarManager. And I actually want to purposely couple the Avatar Firebase service to that Firebase image uploader, because I know that anytime I upload something to the Firebase Avatar service, I also am going to use that as the backend to storing the images for those same avatars. So I'm going to put all the code in here. So let's copy this and actually make a method in our service for create avatar. This way the image uploading is coupled to this service as well. Let's go ahead and say let URL equals try await image Firebase image upload service dot upload image. Let's pass in the image, and we need to pass in a path. Let's go ahead and say let path equals. I'm going to use the avatars slash. Let's use the avatar ID. So I will get the avatar.id from this avatar model. So this first part of the path is going to create a folder called avatars. Within that is going to be a file name called avatar ID. And then inside this function here, it's going to save it as .jpg. So we'll create a path here. And that's all, should be all the code we need now to upload an image. Super quick, super easy. Now that we have this URL, we need to update the avatar model. So inside the avatar model, we have a value called profile image name, which we want to update. So I could change this to a variable, and we can say var avatar equals avatar, and we will mutate this struct. We'll say avatar dot profile image name equals the URL dot absolute string. This works, but earlier in the course I was talking about immutable structs. And part of the reason that we want to use immutable structs is so that we limit mutating this struct to within the struct itself. So now that this is a variable, I am actually mutating this struct from outside of the struct. And I don't like that. I think that's a bad practice. And I think that's generally a bad behavior to get into, because now when you go and you look at the avatar model, you don't really know all of the places in your code base where this is getting changed. And that could lead to bugs. It could also just lead to confusion. So what I like to do is to actually make this a private set var, meaning it's still a variable, but we can only change the variable from within the avatar model. So the setter is private. So now in here, we can create a function, which I will do before the mocks. Let's create a function called update image. And I think we called it profile image. So let's say update profile image. And we'll pass in an image name of type string. And then from inside this function, we will update the profile image name to the image name that we pass in. And we will then go and make this mutating to mark that it is going to mutate the struct that it is inside. So now this code is actually within the avatar model, and the avatar model is still in charge of the mutation, even though this is a variable. So in here, we can now call avatar.updateProfileImage, and we'll pass in our string here. Lastly, let's go ahead and upload the avatar now to our Firestore database. So I'm going to open up another text editor here. On the right, I'm going to go to our user Firebase user service. Let's copy the collection code and create another collection in here, except this will be the collection for avatars. Let's go ahead and import the Firestore packages here. And now I can even copy the same code for saving a user where we set the data. And I can paste it right here. And we'll call this upload the avatar. This is actually update avatar image name. And let's make this the avatar.avatarID. We will set data from the avatar, which will be this updated version of it. And then merge is always true. All right, now the compiler is yelling at us because set data only works if avatar model conforms to encodable. So let's jump to our avatar model. And obviously we want to conform to codable as well as hashable. Let's go through the error messages first. Off the bat, most data types, almost every primitive type in Swift conforms to codable. But when we do this, avatar model does not conform to decodable. It also does not conform to encodable. Now, why is that? Well, if we only had strings and booleans, then this would conform to codable off the bat. But we have these custom types in our avatar model which do not conform to codable off the bat. So let's go ahead into each of these three types now. So I will jump to this one. And let's also make these conform to codable, which they should because they have raw values of strings already. So codable, let's make this one conform to codable and this one conform to codable. If I go back to our avatar model, Command-Shift-K, that error message should go away. Secondly, on the right, I'm going to pull up our user model. In the user model, we already discussed that we like creating custom coding keys so that we can use lowercase snake case. Let's do the same thing for all the data models that we're going to put into Firebase. So down here, I will create coding keys. This one will be avatar ID. Name is the same. Character option. I will copy that, paste it twice. Character action. Character location. This will be profile image name, author ID, and date created. Let's go ahead and give this a raw value of string. And let's jump back to our AvatarManager. I'll X out of the code on the right, and everything should be working. I'll Command R just to make sure everything compiles, and it looks like it will. All right, let's wrap up this video by actually testing this out. So we're going to need to actually inject an avatar service. Avatar service is going to need this function. So let's make our mock also have a create avatar, which we don't need to do anything with right now. Let's come down to our code, and then in here we can just try await service dot create avatar, pass in the avatar, pass in the image. Compiler error, that service is not sendable. We'll make this sendable. And then lastly, let's go ahead and put an avatar manager in our app. So I will jump to the dependencies file that we created a little while back. Let's create an avatar manager of type avatar manager. I'll set an avatar manager equal to avatar manager from a Firebase avatar service. Let's go ahead and add one of these to the environment as well, avatar manager. While we're here, I'm actually going to put these above the other two so that the auth is just the parent most dependency, just as a good habit. Lastly, let's jump to our create avatar view. And I think we're going to need to pull in the new manager. So up here, we'll pull in the avatar manager, and we'll add one to the SwiftUI preview, environment, avatar manager, mock avatar service, and then in here, let's go ahead and try await. Avatar manager dot create avatar. We'll pass in the avatar, and we'll pass in the image. So where is this image? We had up here, I think, generated image is what we called it. And if you remember, the save button is disabled and it is hidden if the image is nil. So if we are clicking on the save button, we can assume that we're going to have an image. So we're just going to do a guard let generated image else return. So this should never fail because the save button would already be disabled. And now we'll just take our image and pass that in as well. We don't even need this comment here. Let's Option Command Enter, open up the canvas, and just make sure the canvas loads first. The canvas is compiling. Let's now go and Command R and build it to a simulator. And let's actually try to upload an avatar. This will be the moment of truth. So let's go to the create avatar screen. Let's create an avatar called Emily. Emily will be a woman that is maybe eating in the city. Generate an image, see what happens. That looks pretty good. Let's generate another image, see if we can get a better image here that looks a little blurry from the AI. Okay, that is way worse. Let's try it one more time. This AI is really tricky with images. Sometimes it's great, sometimes it's not so great. Eating in the city, I guess, is kind of a hard thing for OpenAI. Let's try to get one more good image. And that one might be worse. Let's change eating to smiling. Maybe it can do smiling a little bit better. I don't want to make this the first image in our app when users open the app. That's good enough. All right, Emily is a woman smiling in the city. Let's save it and see if it works. And this printed out, but I don't know what that even means. Let's open up our database and see if it worked. Let's jump to the Firestore database first. We should have an avatars collection with a random generated UID. The author ID is IU4, which should be the user ID that I had. Perfect. We're using lowercase snake case. We can see that the character is smiling in the city. It's a woman named Emily. And we have this URL. If I go and I copy the URL here, I should be able to actually go to this URL and actually see the image. Not the best image, definitely a little blurry, but it did work. Great. So because we saw the URL working, obviously it is actually saved in the storage container, but we can also go to the storage and we should see now an avatars folder, and in here we should see this avatar ID with their profile image, which will go in here, and we can see it here as well. And from here you can also go ahead and click it and open up the URL. But this is working and it's looking great. In the next video, we're going to actually download a bunch of avatars. So what I'm going to do before we end this video is just create a couple more. So let's go ahead and in the Firestore database, I'll just leave this open so that we can see that it's working as we use the app. Let's go ahead and create another one. We'll create Nick. Nick is going to be a dog that is sitting in the park. Just generate that. Looks good. Let's create another one called Steve. Steve will be a cat that is relaxing in the forest, and generate another. You guys can very easily just edit this screen to change the prompts, to change, maybe you want to generate a superhero or something. It should be really easy to actually just change the prompts in here. I like that. Let's go ahead and save it. Let's create another one. Let's do a man that is studying in the mall. The man's name will be Joseph. Let's generate. Go ahead and continue to generate. That is not a great image. I think we can do better. That looks even worse. That one looks fine. Let's go ahead and save that. I'll create a few more before we wrap up here. Let's make this one maybe Olivia, because there is something about Olivia. And we will make Olivia. Olivia is crying in the desert. That should be a hard one for AI to create. Let's see what happens. That is a horrendous picture. I don't know why it just decides to go cartoon mode on us occasionally. But let's go ahead and create another one. I guess it's not good at making deserts. I'm really tempted to tweak this, maybe to change the AI, change the prompt. But obviously we're focused on the code here. These are really bad images. I don't know why this is such a hard prompt. And let's just go with that one. She's crying in the desert. Close enough. We did 1, 2, 3, 4, 5. I will create maybe a couple more, 3 more. Let's do another one to maybe, let's test out our error message. So if I make this say, let's make one with Emma. Emma will be a alien. We haven't done an alien yet. Alien walking in space. That's probably going to be a really hard one for it to create. But what I'm going to do is actually delete the text Emma up here. So now that there actually is no text, when I click the save button in a second, that is a funny picture. When I click the save button, it should actually throw us an error. Please add at least 3 characters. Perfect. We have one bug, which is that this should be set back to clickable again. Let's jump into our code base. And is saving is false. That should happen whether or not we enter the catch. So we'll put this down here. Let's go ahead and build and run it one more time. Let's test that one final time. Maybe we can create another alien. Let's go to our create avatar. Emma is going to be an alien that is walking in outer space. Generate this image. Let's delete the text Emma at the top. Make sure that we get that error message working. Please add at least 3 characters, and the text goes back to save. Perfect. We'll add back in Emma. I'll try to generate one more image. That is not what I expected Emma to look like. But then again, who really knows what aliens look like? All right, I'll generate one more, and these aliens don't look very feminine. So let's change this to Mike. Mike will be an alien that is walking in space, and that looks like Mike to me. All right. Let's do 2 more quickly. Let's do Bella. Bella will be a dog that is working that is working in the park. Generate. That should not really. Bella's not really looking at the camera there. Let's generate one more. And that looks good enough. Bella is looking super cute. Let's go ahead and save that, and then hopefully that uploads as well. 1, 2, 3, 4, 5, 6, 7. When we load this up, we're going to have, I think 7 is enough for us to get going on all of these screens. Awesome. All right, I hope it's working for you guys. I hope you are having fun creating some images here. This is very easy to tweak. Remember that all we did was use the character description right now, but you can very easily maybe jump into here. Maybe you could you can create another variable called AI prompt. Maybe you add more information. Maybe you add in the name here. So, because right now we're not actually sending the name to the prompt. We're just sending a dog that is walking in the park. And then not only can you customize the description, but in the OpenAI service, you can go and customize the AI model that we're using, whether you want HD, whether you want a different style image. So I think there's like vivid as well. I don't know what that difference is going to be, but you guys can play with that and customize it yourself. But anyway, that's all for this video. Pretty cool. We got our uploading working, and now we got a bunch of avatars in our database. Let's Option Command C. I'll make this a feature, and we'll say AvatarManager. Let's go ahead and stage it, commit it. Let's push it up to GitHub, and I'll see y'all in the next video.